Welcome back to the Deep Dive, where we take your source material and strip away the noise, delivering the critical insights you need to be immediately well-informed. Today, we are wading into a really fascinating and, let's be honest, brutally challenging intersection of deep tech and high finance.
The business of biomaterials and bioprocessing.
Exactly. Okay, let's unpack this. Because if you're a researcher or maybe a founder in this space, you already know the core problem. The work doesn't just stop when the science is proven. It's proving the business model works.
Right.
Investors, they're demanding more than just it works beautifully in the lab. They want hard evidence. Evidence that your platform can survive the whole gauntlet.
And that gauntlet is rough.
Yeah.
We're talking everything from variable feedstocks, industrial equipment, regulatory hurdles.
And most importantly, customer economics that actually add up.
Right. Look, technical potential is, well, it's easy to find. Investable execution is the currency that actually delivers returns.
So that's our mission for this deep dive.
Yeah, our mission is to give you a shortcut. We are going to dissect the discipline frameworks, readiness levels, techno-economic analysis, and those tough investor scorecards.
The things that separate the promising platforms.
From the ones that actually scale and capture market share, we're focusing squarely on what turns your technical blueprint into a profitable investment opportunity.
Let's start with a conceptual leap that I think often trips up early-stage companies.
Okay.
Researchers are, they're very familiar with the Technology Readiness Level, or TRL.
Yeah, it's that NASA-inspired scale, 1 to 9. It just tells you how mature your science is.
Right.
So TRL 1 through 3, that's your basic science, your proof of concept. Then 4 through 6 is where you validate it in a lab environment.
And then up to 9 is full commercial scale-up.
Exactly. TRL tells you the technology is ready. It answers the question, can we make this?
But here's where it gets really interesting, because there's another level. The Application Readiness Level, or ARL.
This is the missing piece.
It's the piece that applies the brakes when you try to move that shiny TRL-7 science into the commercial world.
ARL answers the question that the CFO actually cares about.
Which is?
Does it work reproducibly, robustly, and profitably in the intended product format and supply chain? It explicitly adds customer constraints, manufacturing constraints.
And end of life. The part everyone forgets.
The part everyone forgets.
So ARL is where we stop treating the material like this pristine lab sample and start treating it like a real commercial input.
You have to.
Let's drill down on those constraints. Let's take packaging materials first. It's a huge area.
Absolutely. So if you're developing a bio-based film, the ARL gating criteria are intensely practical. I mean, does it run smoothly on existing converting equipment?
The stuff the customer already owns.
Exactly. Basic things like, is the web stable? Does the film tear when it's flying through a machine at 1,000 feet per minute? What's the sealing window?
So the temperature range where it actually seals reliably?
Right. If your material makes a factory slow down its lines by 30%, or they need all new equipment, your ARL is terrible, no matter what your TRL is.
And that just immediately blows up the customer's cost of goods. They're not going to retool an entire factory for one new material.
Never. And then there's the end-of-life part you mentioned.
Yeah, that seems critical now.
It is. You have to prove it works with current recycling or composting infrastructure. If your fancy new biomaterial accidentally contaminates a peat recycling stream.
Which carries huge financial penalties.
Huge. That your material has an ARL near 0. You failed a market test, even with TRL9 science.
And it's not just for materials, right? This thinking applies everywhere, like nutraceuticals.
Precisely. For probiotics or new proteins, ARL demands proven stability and bioactivity in the final dosage form.
Not just in the fermentation tank.
No, the bacteria have to survive pasteurization, encapsulation, drying, and still be effective after months on a shelf in a gummy or a beverage. And it can't taste awful. If your new protein tastes like dirt, your ARL is low, period.
Which brings us to that classic mismatch scenario, that aha moment where TRL just slams into ARL reality.
The nanocellulose barrier film example is perfect for this. The science is, it's phenomenal. TRL 5 or 6, amazing oxygen barrier rates, great tensile strength in the lab.
So investors are getting excited.
They're very excited. But then a major brand tries to run a continuous roll on their commercial equipment. And reality hits. High reject rates, suddenly 20, maybe 25% of the materials being thrown out. Why? The web's not stable, there's static buildup, it's too sensitive to the factory's humidity.
Wow, a 25% waste rate. That's not just an efficiency problem, that kills the whole business model.
It's an existential threat. That reject rate instantly drops the material's application readiness level down to maybe ARL 3. because it just can't perform in a real industrial environment.
And the investor sees that 25% waste and just walks away.
They do the math. They see that as an unacceptable execution risk. So the bottom line is this. TRL tells you the science works. ARL tells you the business case works. And investors, they fund ARL progression. That's the mindset shift you have to make.
That transition to economics is seamless. Now that we know the material has to fit the customer's reality, the ARL, let's talk hard numbers, the TEA.
Techno-Economic Analysis.
And it has to be hard because consumer goods markets are, just brutally competitive. Petrochemical incumbents have decades of optimization.
TE is the discipline that forces you to move past theory. It makes you use real-world metrics from continuous pilot runs, not a single perfect shake flask experiment.
So it's about confronting reality early.
It is, factoring in actual utility costs, labor rates, maintenance, and critically, modeling the volatility and availability of your feedstock.
So the value of TEA isn't just getting a cost estimate, it's about scientifically finding where your business is most likely to break.
That's exactly it. And that is where sensitivity analysis becomes the absolute non-negotiable discipline.
You have to test your model against things you can't control.
Yes. A small swing in one input, something that looks minor in the lab, can absolutely crater your entire economic model.
Okay, give us the concrete numbers on that. This is where engineering hits the balance sheet.
Let's use a lignocellulosic bioprocess. So you're using agricultural residue as your input. Studies show that a 10 to 20% swing in feedstock moisture content.
Which is completely realistic when you're dealing with farm waste.
Oh, totally. That single swing can change your minimum selling price, your MSP, by 15 to 40%.
40% just from moisture. Wow. So a wet batch of feedstock could just destroy your margins.
It destroys the entire business case. Look at these figures. If your biomass comes in dry, best case, maybe 10% moisture, your MSP might be, say, $1.55 per kilogram.
Okay, that looks competitive.
But if that same feedstock is wet, say, 30% moisture, your MSP jumps to $2.15.
That's an extra 60 cents per kilo? You're uneconomic.
You're completely uneconomic. That one variable is the difference between a viable company and a science project.
And there's another layer to TEA now, isn't there? It's not just process costs anymore.
Correct. Modern TA has to include circularity metrics. They are now an economic reality.
They're not just nice-to-haves. They're hard procurement requirements from the big brands.
They are gating criteria for securing offtake agreements. So your TEA must quantify your life cycle greenhouse gas emissions. You need verifiable recyclability metrics that work with existing infrastructure.
Not some theoretical future system.
Exactly. And you have to prove your bio-based carbon content with standards like ASTM D6866. If you can't prove your circularity, you can't get the premium brand contracts.
So it's not just about being cheap. It's about being compliant, scalable, resilient, and climate-friendly.
Yeah.
Cheaply, the bar just keeps getting higher. All right, so we've covered functional readiness with ARL and economic rigor with TEA. Let's move to the final hurdle, the investor scorecard.
The practical grading rubric.
Yeah, this is what VCs use to decide whether to write that 8-figure check.
And this scorecard just integrates everything we've talked about into 5 dimensions. Believe me, investors score these points ruthlessly.
Let's walk through them. Dimension 1.
Dimension 1 is tech and application. The key metric is ARL progression, not TRL. The target threshold for investment is showing ARL greater than or equal to 5.
Meaning validated performance in a real environment with messy inputs and commercial machinery.
Exactly.
That's a high bar. What about actually making the stuff?
That's dimension 2, manufacturability. The metric is your pilot cost of goods sold, your KGS, and your yield consistency over long runs.
And there's a specific target there, isn't there, for something like packaging?
A severe one.
Yeah.
You have to show a plausible path to break even at around 5,000 tons per year.
5,000 tons. Why that number? That seems huge for an early stage company.
Because that's the minimum scale to attract serious Tier 1 strategic partners. Anything less looks like a hobby. Investors need to see that your costs work at a meaningful commercial volume.
Got it. Okay, dimension 3 has to be about the input chaos.
Feedstock robustness. The metric here isn't just having a supplier, it's proving your process can handle variability.
What's the threshold?
Your process has to handle 15 to 30% swings in feedstock composition, say lignin content, without your yield or quality dropping more than 10%.
And that 15 to 30% range, that's based on real-world variability of agricultural waste.
That's what you'll actually see in the wild. If you can't handle it, you'll have ruinous batch-to-batch inconsistency. That's unacceptable.
Okay, Dimension 4.
Regulatory maturity. You need a clear classification and quality roadmap. The target is a defined pathway, like FDA GUIS status, and operating with phase-appropriate GMP, even at the pilot scale.
Build compliance in from day one. And finally, number 5.
Market traction. This is where the customer approves everything else. The key metrics are secured offtakes, joint development agreements, pilot orders.
What's the minimum you need before a big fundraise?
Before Series A, you must have a letter of intent, an LOI, from a credible, recognizable Tier 1 customer. That validates everything.
And speaking of Series A, there's that ultimate financial hurdle.
Right. For these capital-intensive projects, investors often demand a projected risk-adjusted net present value, or NPV, of over 20%.
If your TEA doesn't show that, you're probably not getting funded.
The return has to justify the enormous infrastructure risk.
A very comprehensive framework. Okay, let's wrap this with actionable guidance for you, whether you're a founder fundraising or a researcher scaling up.
For founders, first thing, build your investor decks around ARL milestones, not TRL. Show pilot KGS models tied to real continuous run data.
And don't forget the sensitivity analysis.
Never. Show it for your top 3 cost drivers. Prove you know where you're vulnerable and how you'll fix it.
What's the second piece of guidance?
Get one credible customer LOI before Series A. Internalize this. Lab data plus spreadsheets. That's just storytelling.
But lab data plus pilot economics plus customer validation.
That is de-risking. And de-risking is what secures investment.
And for the technical audience, the scientists and engineers in the lab right now,
your data collection has to change. When you run your design of experiments, your DOE, you must start using realistic, worst-case feedstocks.
Not the pure, perfect stuff from a catalog?
No. Document how your yield holds up when cellulose content swings 20% or when mixing time doubles at pilot scale. That variability data is gold.
And they need to learn to connect the lab to the business.
Yes. Learn to translate your unit operations into unit economics. Stop focusing only on lab metrics. Investors want to know how your 10% tighter improvement lowers the MSP by 5 cents. Make that direct connection.
That's the key.
And remember this warning. If your investor deck lacks pilot scale, KGS models, and a clear ARL progression story, you're not de-risking a business. You're storytelling about science. And investors only pay for de-risking.
That is an essential truth. It shifts the goal from winning a science prize to building a resilient company. So here is a final provocative thought for you to mull over. The best biomaterial platforms aren't the ones with the highest TRL scores. They are the ones with the most balanced scorecards across all 5 dimensions: application readiness, manufacturability, feedstock resilience, regulatory clarity, and critically, customer validation. That complete integrated profile is the only one investors can write those big essential checks for. Thank you for joining us for this deep dive into the true business of biomaterials. We hope this framework helps you turn your technical promise into undeniable, investable execution. We'll see you next time.